So finishing up with chapter or section 2.6. So we got 2.6b today, which has to do with our rational functions still. And today we're really gonna, after we figure out how to find the horizontal asymptote, then we're gonna sit there and put all of the stuff that we've learned under these rational functions together, so that way we can graph them nice and pretty. Okay, so I'm gonna write a really confusing kind of like little formula, but I'll explain it. Right, so when we have a rational function, our f of x, we know that it's like a function over a function, right? So I'm going to write kind of a mathematical way that we write functions. I'm going to take out some of the stuff, but like you usually have a leading coefficient, and then you have your variable x, and it's raised to some degree, right? Make sense so far? And if we want to continue that on, then you would have x to a degree, but that degree should be one less than the previous one, right? Because we have it in standard form, which is from highest to lowest. And then so our next term would be x to the n minus 2, because we're going down another one, or 2 from the first one, right? And that kind of keeps continuing until you get down to where you have x to the first, right? And then we usually, not always, but we usually end it with some constant term, and we just say that that's a sub 0 or a naught, right? And since it's a rational function, we know that it's going to be a fraction, and then we really have the exact same thing underneath, except for we're going to change our variables a little bit, or our letters. So instead of a, we're going to use b, because they don't have to be the same, right? It doesn't have to have a 2 on top and a 2 on the bottom. It can be any number. But we still have an x, and it's to some degree, and we're going to say that's m, because it doesn't have to be the same degree as the one above. And then that same principle would apply, right? You would have your next term, and that degree would be one less than the first one. And then you'd have another term that would actually be 2 less than that very first term, or 1 less than the one before. And that would kind of keep continuing until you get x to the first degree, and then usually, not always, but sometimes we get that constant term. So we're just going to call it a, or b naught, or b sub 0, right? So you're like, what are you showing me, Mrs. Fitch? So when we're trying to look for these horizontal asymptotes, really what we're focusing on is going to be this part right here. So that leading coefficient and that leading degree. All right. So we want to talk now about horizontal asymptotes and what all of this means. So if I were to draw out a graph, right, something along this line, right, and I'm looking for a horizontal asymptote, horizontal would be going in like this direction. So say we had a horizontal asymptote when, y equaled 3. So it would be something like this. So that would be the line that we're getting really, really close to, but we can't be. Okay? So we want to focus on this first part of our rational expressions, because that's going to tell us where or if we have those horizontal asymptotes. So numerator and denominator, we know those, right? This is my, yep, good answer, numerator. And this one is my denominator, right? And we're going to be looking at the degrees. So we're going to be looking at this n, and we're going to be looking at this m. And there's 3 different cases we need to look at. So the one is if n is less than m. So n would be in the numerator, right? And m is in the denominator. So if our degree in our numerator is less than our degree in our denominator, then the x-axis, which is the same thing as when y equals 0, is your horizontal asymptote. And I'm just going to put HA in there. All right, you good with that one? And we'll go through some examples. So the next one would be, so if n isn't less than m, maybe n equals m. So that's saying when you look at that leading term on your numerator and denominator, this degree and this degree are the exact same thing. So if they are the same, then the line A over B is your horizontal asymptote. So on this one, if your numerator degree and your denominator degree are exactly the same, then you're going to look at that leading coefficient, and whatever that leading coefficient fraction is, that A over B, that ratio, that's going to be where your horizontal asymptote is. So like if this was a 2 and this was a 1, just for poops and giggles, 2 over 1 is 2, so you're going to have your horizontal asymptote when y equals 2. I guess I should have used 3 because I had that up here. All right, so then there's going to be one other possibility, right? If, what would it be? If n is, yeah, good job, greater than m, then there is no horizontal asymptote. So if your degree in your numerator is higher than your degree in your denominator, there isn't a horizontal asymptote. So there's nothing you can do on your problem for a horizontal asymptote. All right. Ready for 3 examples? Actually, I think I can just fit it all right here on the sheet. We're going to try. We're going to go for it. All right. So let's say for A, let's say we have 4x divided by 2x squared. And why not throw a plus 1 in there just for poops? Yeah, we don't need a plus 1. We're just going to leave it that way, right? So if it helps that x is actually technically to the first degree, so if you need to put that on there, go ahead and put that on there, right? Our n is our highest degree in our numerator, which is going to be 1. And our m is going to be highest degree in our denominator, which is going to be the 2. So now I'm looking at 1 and 2. So then now fill in the inequality. So you're either going to fill in 1 is less than 2, you're going to fill in 1 is equal to 2, or is 1 greater than 2. After great time and pondering, we know that 1 is less than 2. And now that we know that 1 is less than 2, we're going to look for that up in our little 3 scenarios, which is this first one. So what is our horizontal asymptote? It's going to be when y equals 0. So when y equals 0. Right. If I'm losing you, let me know. So let's try another one. Let's say we had 4x squared plus 3x minus 1 over 2x squared plus 5. So we're going to do the exact same thing that we just did. Right? I'm going to find my n. My n is my highest degree in my numerator, which is going to be the 2. I'm going to do the same thing for the bottom, and my highest degree is going to be a 2. So I'm going to do my little 2 and 2. We know that those babies are going to be equal, which is going to be this second one. So then it's going to be the line A over B. So the line A over B, so y is going to equal, my A is 4, my B is 2. So y is going to equal 2. Think I can fit one more on here? We'll try. Let's say we had 4x to the third minus 3x squared plus 5. Just making stuff up, right? And let's say we had 3x squared plus 4x minus 6. So same thing. I'm going to look at my numerator, and I like it because N stands for numerator, right? So hopefully that'll help you know to look at the top. My highest degree is 3. When I look for my M, my highest degree in my denominator is 2. So I'm going to look at 3 and 2. I'm going to fill in my inequality. I know that 3 is greater than 2. So when I look back at my scenarios, if it's greater, if N is greater than M, what do I have? No horizontal asymptote. So no horizontal asymptote. Not too bad? All right. So we're going to try and take all of this together, and we're actually going to turn this into a graph. So I know in our textbook they talk about the 7 steps to graphing. We're only going to really do like the 6 steps of graphing. The one had to do with odds and evens and the symmetry. So that one we kind of like time constraints. We're like, you know what? It's good to have, but we don't need to have it. So we're going to do 6 steps instead of the 7 steps. So in the homework assignment, when it asks about the odds and the even, you don't have to worry about it. All right. Whoop, 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 whoop. Me and this computer. All right. So we want to stay. We want to graph f of x equals 3x squared over x squared minus 4. So I'm going to start by drawing a nice little big xy axis. I think that'll work for us, right? And then we're going to go through these 6 steps. So 6 steps. You get your steps in on your little activity tracker. That was a joke. Laugh, guys, laugh, laugh. All right. So the first thing we need to find when we're going to figure out how to graph these, and they don't have to be in this order, so, but the first thing I'm going to find is my y-intercept. And my y-intercept is where I cross the y-axis. And I always know that if I'm crossing the y-axis, my x value is always going to equal 0. So in order to find that, I'm just going to plug 0 into my equation for x. Right? So I'm going to find f of 0. So 3 times 0 squared divided by 0 squared minus 4. What are we going to get? 0 over negative 4, which is going to give us 0. Right? So I know that when it comes to my graph, I am going to have it's going to go through the point 0, 0. Right? So now that I found my y-intercept, I bet you guys can figure out the second step. What's the second one going to be? You guessed it, the x-intercept. So if I'm looking for my x-intercept, I know that's when my y equals 0, right? So I would have 0 equals 3x squared over x squared minus 4. I don't like the x squared minus 4 on the bottom because it's my denominator. So I'm going to multiply both sides, right, by x squared minus 4. That's going to cancel those babies out. So now 0 times anything is 0. So now I get 0 equals 3x squared. I'm going to divide by 3, which is going to give me, I'm just going to go this way so I don't run out of room. 0 equals x squared. So then I know that my x is going to equal 0. Your x-intercept and your y-intercept are not always going to be the same, and just happen to be with this one, right? So I know that I'm going to cross the x-axis at 0, 0. So number 3, I am going to look for those vertical asymptotes, which is what we worked on in the previous lesson. So to find my vertical asymptotes, I'm looking for those values in my denominator that could possibly make that 0, because we know we can't divide by 0, right? So I'm going to set my denominator equal to 0. So x squared minus 4 equals 0, right? Add 4 to both sides. X squared equals 4. Take the square root of both sides, and I know that x equals a positive or a negative 2. So now on my graph, x, I know I'm going to have where x is asymptotes when x is 2 and negative 2. So on my graph, I'm going to draw in those asymptotes. So at negative 2, I'm going to draw that dotted line, right? And at a positive 2, I'm going to draw that dotted line. Fourth thing I'm going to do is I'm going to look for my horizontal asymptotes, which is what we just did today, right? So I'm going to look at my degrees. So when I look at my degrees are the same thing. And then when my degrees are the same, that would be this one, the second one. When they're the same, I know that my line is going to be A over B. And again, on this one, if it helps out, if you want to throw a 1 out front, throw a 1 out front, right? So my horizontal is when y equals A over B. So that's going to be when y equals 3 over 1. So when y equals 3. So I'm going to go back to my graph, and I'm going to go, okay, so 1, 2, 3, here's y equals 3. And now I'm going to have a horizontal asymptote going this way. Might extend that a little bit more. So now we have a whole bunch of these little areas that we know that our graph has got to be somewhere in. So we need to kind of figure out where these are all going to happen. So the fifth step, I think, has to do with the odds and evens type thing. So I think then we just like skip to 6. Actually, you know what? 1, 2, we'll just call it 5, right? So on 5, we need to plot some points on either side of the asymptotes. Okay. And this is y. Right? So my graph, if I look all the way over to the left, I have this horizontal asymptote and I have this vertical asymptote. So I know that I can use my x values. I can use like x is 1, 2, 3, negative 4, right? But where is that going to land? Is that going to land somewhere down here, or is that going to land somewhere up here? So when it comes to these horizontal asymptotes, we don't know if our graph is going to be in this area or if it's going to be in this area, right? So that's why we have to check out some values and see what happens. So we just got to pick a number. So what do we want to pick? So we know we can't put in -4 because that's a asymptote, but we can do -3, -4, -5, whichever one you want to do. It's just to sit there and figure out where it's going to land. So I don't know, let's just try. How about -3? And I think I'm just going to write these babies all over the place. So let's try it over here. So let's say I want to find f of -3. So I'm going to plug in -3 for x, right? And we're going to put some of this together. So if I put in -3, -3 squared is going to be a +9, yep, over 9 minus 4, which is going to give me what, 27 over 5? And I don't know, that's going to be what, 5 goes into 27 5 times, gives you 2 left over, so 0.4, 5.4-ish, somewhere along that lines. So if I'm at -3, my y value is at 5.4. So 1, 2, 3, 4, 5. So it's up here somewhere. So that's telling me that my graph is in this area, right? And we know that when it comes to asymptotes, we can get really, really close to asymptotes, but we can't be them. So as x is coming over from -infinity, like it's ultimately dropping down to this axis, or to this asymptote. And then when it gets to this asymptote, it's got to go either up or down. Well, it can't go down because you got a little block there, right? Because of the intersection of those asymptotes, so it's got to go up. So when we draw it, we just kind of perfectly draw like a little curve like that. So I got really close to this asymptote, but I couldn't be it. I started getting close to my vertical asymptote. I can't go down, so I have to go. Oh boy, this thing's doing it for me. I don't want it to do it for me. Maybe if I just go quicker, then I'm going to go up. And of course you can see mine's not perfect, but you get a very good indication of it, right? All right. So then I'm going to try another value, and now I'm going to go somewhere in between these 2 points, because again, my graph could go this way. I bet you it's not going to because of that asymptote. I bet you it's going to go this way. But just to be sure, I'm going to test a point. So I'm going to test -1. So then I'm going to test f of -1. So we're going to do this all together, right? -1 squared is 1. 1 times 3 is 3. -1 squared is 1. 1 minus 4 is -3. So f of -1 is going to equal -1. So when I'm at -1, my y value is -1. So I know I have a point here. Oh, I guess I could change colors again. So then I know that from this point, I'm going to go down, and I'm going to get close to my asymptote, but I'm not going to touch it, right? I think you guys can figure out what's going to happen to the right of this point. You think it's going to go like this? Probably not, right? Because you got these asymptotes. So guess what it's going to do? It is going to go down. And to check it, plug in that value for 1. It only takes 7 seconds, right? F of 1. 1 squared is 1. 3 times 1 is 3. 1 squared is 1. 1 minus 4 is -3. So we know that that's going to be -1. So we were right. So that's going to go here. Plot that point, and your graph's going to go this way, right? So now we need to figure out what's happening as our x value is going to infinity. Because we could either be here or we could be here. So we got to figure out which little part that we're at. So we're going to pick a value. We know we have this asymptote at 2, so we got to pick a value bigger than 2. How about 3? I like 3. So f of 3 is going to equal 3 times 3 squared. 3 squared is 9 over 3 squared is 9 minus 4. So that's going to give us 27 over 5. And guess what? We already did that. And what did we get? We had approximately 5.4, right? So we know that when our x is 3, our y is 5.4. So we know we're up in this area. So when it comes to graphing, when I get close to this asymptote, right, I'm going to get close, but I'm not going to touch it. And then I'm going to start coming towards this asymptote, but I'm going to get close, but I'm not going to touch it, right? So I'm going to get that little guy, and then this little guy. And look at that. You guys just sat there and graphed a very crazy, wild function. Yeah. And so step number 6 is graphing it, right? Which we just, honestly, I plot the points and I graph it as I go, right? Instead of plotting all of the points, figuring out where it is and then graphing it. I think graphing it as you go is easier than waiting until the end,